AP Calculus BC, Unit 5, Day 1, Integration by Fraction. So, we will be learning new integration techniques that you've never seen before from last year, but we will also be reviewing integration techniques from Calc AB. So today's mainly a review. You can do it on your own sheet of paper. It's not that much notes. So if I were to give you a note sheet, it'd be almost blank. So you can just do your own. Section 1, integration of fractions, as opposed to by fraction. It'll make more sense as we do this. Integration of fractions. So if we had an integral, like say x squared over x cubed plus 2 dx, how would we integrate that? I think one thing that you should potentially consider is U-Substitution. The denominator is usually good U equals x cubed plus 2. Du equals 3x squared dx. You'll know if it works or doesn't. You should get this x squared dx, and there it is. I don't want the 3, so I'm going to divide by the 3. I'm going to rewrite this as 1/3 goes on front, du over u. The antiderivative is natural log of the absolute value of u plus c. So we get a lot of natural logs for antiderivatives of fractions. You want to rewrite it back in terms of the original variable, natural log of the absolute value of x cubed plus 2 plus c. The thing you should ask yourself is, can I get rid of these absolute values? Is the inside always positive or always negative? Could be positive, could be negative, so I'm going to leave it. So the rule that we just used that you could maybe add to your notes is the integral of du over u is natural log of the absolute value of u plus c. So that's one of the big rules we will be using. Okay. Second group of problems might involve the power rule. So let's do an example that is like that. X dx over the square root of x squared plus 1. Again, U-substitution is something to consider. U equals x squared plus 1. Usually the denominator or what's inside the denominator, du equals 2x dx. You should know right away if it's going to work or not. If you pick the wrong u or u's going to work at all. Any extra numbers are easy to fix. So that's going to be 1/2 integral of du over the square root of u. So there's still a square root there. Now this is not going to be natural log. This is going to be a power rule. You want to rewrite this as u to the negative 1/2, which is a power rule. So we're going to increase it by 1 and divide by the new exponent, multiply by its reciprocal, plus c. The 2's cancel out. So our answer is the square root of x squared plus 1 plus c. So the rule that you might also use sometimes is the power rule. U to the n du equals u to the n plus 1 divided by the new exponent plus c. So keep that one in mind. Okay, section number 3, inverse trig. There are some weird fractions that we get that are the derivatives of inverse trig that we're trying to undo. So, for instance, x squared over x to the 6 plus 1 dx, you probably would try U-substitution at least in your head, because if it works, that's the way to go. Don't make problems worse than they have to be. And this one is no good because we need x squared dx, and this has x to the 5th, so that's not going to work. So something to consider might be a rule like this. Integral of du over 1 plus u squared is inverse tangent of u plus c. So kind of giving you guys some strong hints, but now we will get back in the hang of recognizing these ourselves. So a lot of times it's not going to look exactly like that yet. Like this is where the u squared goes, right? So we are going to use u substitution. U equals, we got to figure out, well, what do we put in here to get squared? It'd have to be x cubed. That's going to be your u. U is x cubed. D equals 3x squared dx, which actually makes perfect sense. We wanted x squared dx. Got it. So we divide by 3. We rewrite it 1/3 du over u squared plus 1, which is the same as 1 plus u squared. That's fine. So the answer is going to be 1/3 inverse tangent of u plus c equals 1/3 inverse tangent of, right in terms of the original variable, x cubed plus c. And that's your answer. Now, there are some other inverse trig antiderivatives, so maybe we should show another example. Let's say you had x over, well, actually, we could write another one here. Du over the square root of 1 minus u squared. Now, it does need to be 1 minus u squared. That's going to be inverse sine plus c. Now, inverse cosine, we don't use it. I mean, the main reason you need it is if you're taking the derivative inverse cosine. But for antiderivatives, it doesn't matter because the only difference is it has an extra negative. And then that gives you inverse cosine, which means we could just use inverse sine. We could just put a negative in front of it, right? So, I mean, that is another rule, but this could just be negative inverse sine. So we don't need inverse cosine, but there it is. But probably not going to use it. Let me just give you another sort of challenging problem that actually is related to inverse tangent. We could try u equals x to the 4th plus 9, du equals 4x cubed dx. That's no good. We want x to the 1st dx. So we think, well, I mean, I always try that first because sometimes it's going to be that easy. I'm not going to get into the weird ones unless I've ruled out the easy ones. So I'm thinking, okay, well, maybe this is something squared. But there's another issue here. This needs to be a 1, okay, before you even figure out what goes here. And so you need to factor the 9 out. Now, when you factor the 9 out, you could just put it out in front. So we're going to divide a 9 out, but that also affects this x to the 4th. It's going to be x to the 4th over 9 plus 1. So you need to do that. You need to make that a 1 first. Then you could say, okay, well, what do I square? X squared over 3. So when you factor 9 out, it affects what your u is going to be. So u equals x squared over 3, du equals 2/3 x dx, which is what we want. So we're going to have 1/9. I don't want the fraction. So there's another 3/2. Put it out front. Du or u squared plus 1. So the answer is going to be 1/6 inverse tangent of u plus c, which equals 1/6 inverse tangent of x squared over 3 plus c. So sometimes they get a little challenging there. You got to make that a 1 though first, okay? Today's assignment is worksheet 5-1. And you will be using all of these techniques on it. This is all review today. We will be getting some new techniques soon, but let's master these first. And go ahead and try the assignment. Check your answers, make sure you're good at all these.